Hello everyone, good evening. So here we shall solve some new JEE Mains previous year questions on the chapter properties of matter. So any doubts if you have in any steps, then please write that in the comment section. We shall obviously clarify them in the subsequent videos. Also in any other chapter of physics, if you have no difficulty, then please mention the name of that chapter also in the comments section so that we can give more priority on it and solve more and more questions on that chapter. Also, some important homework questions on every chapter will be uploaded in the Sapience education application. Mm, whose link has been provided in the description. So here it has been told that a drop of a liquid of density rho is floating half immersed in a liquid of density sigma. So a drop of a liquid that is half immersed in a liquid of density sigma, and tension surface tension is 7.5 into 10 power minus 4 Newton per centimeter. The radius of the drop in centimeter will be. So there is surface tension. So obviously the force will be surface tension into the length. The length around which the surface tension force will act is around the circumference. So that will be S into 2 pi r. Obviously, the buoyancy force will also act. Buoyancy force that is a big heave volume which is immersed, that is half of the volume. So it is 2 by 3 pi r cube into sigma into g. And this is S into 2 pi r s. This is also the force due to surface tension. And this is Ng. So the net upward force would be equal to the net downward force. Therefore, I can say V, that is 4 by 3 pi r cube into rho into g. That is equal to 2 pi r s plus 2 by 3 pi r cube into sigma into g. Pi will cancel. So 2 over 4 will cancel out. So r square will be there. There r square will be there. This will be 2 by 3 r square rho into g, that is equal to s plus this will be r square sigma g by 3. The radius of the drop we have to find out. So this will be r square rho into g. So r square g I can take as common into 2 rho by 3 minus sigma by 3, that is equal to s. So therefore r square g by 3 into 2 rho minus sigma, that is equal to s. So therefore r square, that will be equal to 3s by g into 2 rho minus sigma. Therefore, the square of the radius, that is 3s, 3 into s, 7.5 into 10 power minus 4 Newton per centimeter, but we have to convert to Newton per meter. Newton per meter we have to convert, so this will be in centimeter into asked, right? So this will be 7.5 into 10 power minus 4 Newton by 1 centimeter is 10 power minus 2 meter. So this will become 10 power minus 2. So 7.5 into 10 power minus 2 Newton per meter. This is the surface tension divided by G, which is told to take as 10. 10 into 2 rho minus sigma. So this will come in meter square. So this will be r square. That will be 3 into 75 into 10 power minus 3 by 10 is into 10 power minus 1 divided by 2 rho minus sigma. This much meter square. So this will be r square, that is 3 5s are 15. So that 21 to 25 into 10 power minus 4 divided by 2 rho minus sigma into meter square. Now 1 centimeter square, that is equal to 10 power minus 4 meter square. So this 10 power minus 4 meter square, I can write it as 1 centimeter square. So this will be, so r square will be 225 by 2 rho minus sigma, this in centimeter square. So therefore r, if we take the square root on both sides, so r will be 15 by root over 2 rho minus sigma centimeter. So in centimeter, answer is 15 by in centimeter, the answer is 15 by root over 2 rho minus sigma. So option A is the correct answer. Then it is told an air bubble of negligible weight having radius r is having negligible weight, so mass is approximately 0 only. Is having radius r. It rises steadily through a solution. Will rise steadily means the speed will be constant through a solution of density sigma, and the coefficient of viscosity of the solution is 1. So let's say the coefficient of viscosity of the solution is eta. So then we have to find the value of the eta. So obviously mass, which is 0. So it is rising upwards. So the viscous force is acting downwards, but the buoyancy force is acting upwards only. So therefore, viscous force that should be equal to the buoyancy force. Mg weight is approximately 0. So the viscous force, that is 6 by eta Rv, that is equal to the buoyancy force, which is 4 by 3 pi r cube volume into sigma into g. So this will be the 4, which will be a 6 r square pi also will cancel. This is 3 eta v, so that is 2 r square sigma g by 3. Therefore, eta, that will be 2 r square sigma g by 9 eta. 2r square sigma g by, sorry, 9v. Theta is here, so 9v. 2r square sigma g by 9v. So option B is the correct answer. It is told a wire of length L is hanging from fixed support. Wire of length L is hanging from fixed support. The length changes to L1 and L2. A wire of length L is hanging from a fixed support. The length changes to L1 and L2 when masses of 1 kg and 2 kg are suspended respectively but on free end. So the length is L1 when mass M is 1 kg, means when the load mg will be equal to 1 into g, that is g Newton, and the length will be L2 when the weight mg, that is 2g in Newton. Then the value of L is equal to, so L is the natural length. So here we can say the force, as you know, mg that is equal to ya by L into x, or into delta L. So when delta L is the change in the length or the amount of extension of the wire. Delta L is the extension in the wire, and ya by L, y is the Young's modulus, and A is the area of cross section, and L is the length mg. Mg. We can say first case here, here delta L will be L1 minus L, and in the second case delta L will be L2 minus L. Therefore, in the first case the load is G. G is equal to, I will say, Ya by L. Y is the Young's modulus of the wire, Ya by L, and area of cross section will not change. Y by L into L1 minus L, and 2G, that P also equal to Ya by L. So 2G, that is equal to Ya by L into L2 minus L. Now, if we divide the equations 1 and 2, then we will get 2G by G, that is equal to L2 minus L by L1 minus L. G and G will get cancelled. Then we can say 2L1 minus 2L, that is equal to L2 minus L. So therefore, I can say that 2L minus L, that is equal to 2L1 minus L2. So it means L will be equal to 2L1 minus L2. 2L1 minus L2 is the length. Option C is the correct answer. Then it is told a block of metal weighing 2 kg is resting on a frictionless plane. Kg is resting on a frictionless plane as shown in the figure. So here it is smooth only. It is struck by a jet releasing water at the rate of 1 kg per second and at a speed of 10 meter per second. Then the initial acceleration of the block. Initial acceleration of the block in meter per second square will be how much? So mass into acceleration is equal to the net force acting, and net force acting is the change in the momentum. So initially the velocity of the block will be zero only. So I will say d into dm by dt for but dm by dt here it is the rate at which mass of water is being released, which is 1 kg per second. The V is this, V is 10 meter per second. So therefore the net force acting that is equal to V, which is 10 into 1. So this is your meter per second and this is kg per second. So this will be kg meter per second square. So this is 10 kg meter per second square and this is 10 Newton I can say. So therefore mass into acceleration, so 2 into A, that will be equal to 2 into A, that is equal to 10 Newton. In A, mass into acceleration, that is equal to 10. So therefore A will be equal to 5 meter per second square. So option C is the correct answer. Then it is told water drop of radius 1 micrometer falls in a situation where the effect of buoyant force is negligible. And the coefficient of viscosity of air is 1.8 into 10 power 5 Newton second per meter square, and its density is negligible as compared to that of 10 power 6 gram per meter cube. Water drop is there. It is having radius 1 micrometer, which is 10 power minus 6 meter. It falls in a situation where the effect of bind force is negligible. Falls in a situation where the bind force is negligible, so it means P sigma G, that is approximately zero. The coefficient of viscosity of the air, that is 1.8 into 10 power minus 5 newtons per meter square. And the density is negligible as compared to that of water. The density of air is negligible. It's much less than the density of water, which is 10 power 6 gram per meter cube. Density of water is 10 power 6 gram per meter cube. Now the terminal velocity of the water drop is. So it means it is volume downwards. So the net force downwards is the weight mg, and the upward force is the 6 pi eta rv, which is the viscous force, and buoyancy force is zero only. So that for terminal velocity, the two forces should be equal and opposite. Means V rho g, that is equal to V water drops. So V into volume into density of water into G, which is the mg only. That is equal to 6 pi eta rv. And volume, that is obviously 4 by 3 pi r cube. Density of water into G, that is equal to 6 pi eta rv. So hence the terminal velocities, that will be 4 pi r cube 4 pi r cube rho w into G divided by 3 into 6 pi eta r. 4 pi r cube rho w into G by 3 into 6 pi eta r. Pi will cancel, and then r square will be there. 2 3 or 6, 2 3 or 4. So this will be r square rho w into G by 9 eta. R square So therefore the terminal velocity, that is 2r square rho w into G by 9 eta. This 2r square, that is r is 1 micrometer, means 10 power minus 6 whole square, into density, that is 10 power 3 kg per meter cube, 10 power 3 into G, that is 10 divided by 9 into eta. Eta is 1.8 into 10 power minus 5. V is 1.8 into 10 power minus 5. So we can say 2 9s are 18, 0.9. So this will be 10 power minus 12 into 10 power 4 divided by 9 9s are 81 into 10 power minus 6. So this will be 10 power minus 12 plus 10 by 81, which is 10 power minus 2, which is 1 by 100 into 1 by 81. Therefore, the terminal velocity is 8100 meter per second. So this is approximately 0.0001346, approximately this much meter per second. It is approximately 123.46 into 10 power 123.46 10 power minus 6 meter per second. 3.45 power. So option D is the correct answer. Then it is told given below are two statements on is labeled as assumption. Okay. So here the assumption has been told that product of pressure and time has the same dimension as that of coefficient of viscosity. So for the coefficient of viscosity eta, product of pressure and time, dimension of coefficient of viscosity. So coefficient of viscosity, I can say that will be equal to force, the viscous force by 6 by eta, 6 by RV. So the product of pressure and time if you do, so it is force by area into time. So this I can say force by area by time, which is length into some length by time, which is like speed only. So force by length into this speed v. So obviously here we can see that the product of pressure and time, it is having the same dimension as that of the coefficient of viscosity. And similarly, quotient of viscosity, we can also say the force by velocity. Okay. Force actually, the viscous force that is equal to minus eta A into dv by dx. But hence it means coefficient of viscosity that is equal to force divided by area into velocity gradient. Force by area into velocity gradient. So coefficient of viscosity is not force by velocity gradient. We can say it is pressure by velocity gradient, that we can say. So hence the assumption is true and the reason is false. So option C is the correct answer. When it is told a water drop of diameter 2 centimeter, water drop is there is it is diameter is 2 centimeters, so the radius is 1 centimeter, and it is broken into 64 equal droplets. This is 1 centimeter. Then the surface tension of water surface tension of the water is 0.075 Newton per meter. Then it is told in this process the gain in surface energy will be. So the gain in the surface energy that will be equal to surface tension into the change in the surface area. That will be S into increase in the surface area. So that is final area minus initial area. So final surface area that is equal to 64 into 4 pi r square. Initial surface area that is 4 pi capital R square. Now we have to find the relation between small r and capital R, where small r is the radius of each equal droplet. Therefore, the volume we can take it same. The initial volume will be equal to the final volume only, since mass is conserved. We have to apply the law of conservation of mass, law of conservation of mass. So initial volume that is 4 by 3 pi capital RP that is equal to final volume which is 64 into 4 by 3 pi small RP. So these two will get cancelled. So therefore RP that is equal to 64 RP. Therefore R will be equal to 4R. R will be equal to 4R. Therefore R will be equal to R by 4, which is 1 by 4 centimeter. So therefore the gain in the surface energy that is delta E that will be equal to S into A final, that is 64 into 4 pi r square. So S into A final, that is 4 pi r square, 4 pi into is 1 centimeter, so 10 power minus 2 meter whole square. This will be final area, that is 64 into 4 pi small r square, which is 1 by 4 centimeter, means it is 1 by 4 into 10 power minus 2 whole square minus 4 pi r square, which is 4 pi into 10 power minus 2 whole square. S is 0.75 Newton per meter. It is 0.075 into, that will be 64 into 4 pi into 10 power minus 4 divided by 4 to the 16 minus 4 pi into 10 power minus 4. This will be 16 for the 64. This will be 4 pi, so 0.075 into 4 pi into 10 power minus 4 into, this will be 4 minus 1. 4, 5, 20. 4, 7 is 28. So this is 0.3 into 3 pi into 10 power minus 4 joule. So this will be 3 pi, that is 9.42 into 0.3 into 3 into 0.3 into 10 power minus 4 joule. So it is 3 4 6, 3 4 12, which is a 9, 10. So 1.026 into 10 power minus 4 joule. That is equal to r by 4, so 1 by 4 centimeter. So this is 0.34, 0.075 into 4, 4 5 20, 4 7 28, 30, 3, 0.3 only, 0.3 pi into 3 into 10 power minus 4. 3 pi is 3.14 into 3, that is 3 to the 12, 3, which is 9.42 into 2.339, 27, so 9.42 into 3, 3 6, 3 4 12, 3 9s are 27, 28, so it is actually 2.826 into 10 power minus 4 joule. So 2.8 into 10 power minus 4 joule. So option A is the correct answer. Then it is told, when a ball is dropped into a lake from a height 4.9 meter above the sea level, when a ball is dropped into a lake from a height 4.9 meter above the water level, it hits the water with a velocity v. The ball is dropped into a lake from a height of 4.9 meter above the water level. It hits the water with a velocity v. It hits the water with a velocity v and sinks to the bottom with a constant velocity v. It reaches the bottom of the lake 4 seconds after it is dropped. The approximate depth of the lake will be how much? It's the depth of the lake that we have to find out. So V is 9.8. So here how much time it will take to cover this height, that will be equal to, or this initial velocity is 0 only when it is dropped at t equal to 0, and at t equal to 4 seconds it will reach the bottom of the lake. So then tell h will be equal to ut plus half g into t square. Let's say t1, at time t equal to t1 it will reach the surface of the lake. Therefore h, that is 4.9, that is equal to 1 by 2 into 9.8 into t1 square. So 2 4 is 8, 2 9 is 18, so t1 square, that is equal to 1, so t1 will be equal to 1 second. So at 1 second it will reach the surface of the lake, and so 3 seconds it will take to cover this depth of the lake. So depth will be equal to v into t, it is equal to v. So with what velocity it will hit the surface of the lake, that is v is equal to u plus gp, 9.8 into 1, so that is 9.8 meter per second. So t will be 9.8 into 3, which is 3 8 24, 9 27, 29.4 meters. So the depth of the lake is 29.4 meters. So option B is the correct answer. And here it is told the velocity of a small ball of mass m and density d1 when dropped in a container filled with glycerine becomes constant after some time. The velocity of a small ball of mass m and density d1 when dropped in a container is dropped in a container filled with glycerine. Is filled with glycerine becomes constant after some time. That is the terminal velocity v. If the density of the glycerine is d2, then the viscous force acting on the ball will be how much? The viscous force, that is So that will be how much? So you can say that when the velocity will be constant, then mg will act downwards, and the buoyancy force, that is v into d2 into g, will act upwards, where v is the volume of the ball, that is mass by density of the ball, which is m by d1. So therefore, viscous force, the net upward force will be equal to the net downward force. So viscous force plus the buoyancy force, that is equal to mg, which is the weight. So viscous force, that will be equal to mg, that is mg minus fb, that is v into d2 into g, which is mg minus m by d1 into d2 into g. So therefore, the viscous force, that is equal to mg, I can take as common, mg into 1 minus d2 by d1. mg into 1 minus d2 by d1. So option B is the correct answer. It is told that if P is the density and eta is the coefficient of viscosity of the fluid which flows with a speed v in the pipe of diameter d, the correct formula for Reynolds number Re is. P is the density, P is the density, P, or here actually rho I have to tell. Rho is the density and eta is coefficient of viscosity of fluid which flows with a speed v in a pipe of diameter d. The diameter is d. The correct formula for Reynolds number Re is. The correct formula for Reynolds number Re will be. So the Reynolds number, as you know, it will be. Now we can use the dimensional analysis. Reynolds number, that is a dimensionless constant. It will be dimensionless. So therefore, if I am eta, that is Re, I can say that is eta power a rho power b into v power c into d power d, d power e, suppose. So then the coefficient of viscosity eta, that is force by 6 by eta Rv, 6 by eta Rv, that is F. So eta will be F by Rv, means length into velocity. Means it is mlt power minus 2 by length into length lt power minus 1. So this is m into l power minus 1 t power minus 1. And rho, that is mass by density, so mass by volume, that is ml power minus 3, and e is the speed, that is lt power minus 1. And similarly the the diameter, that is L. So therefore, Reynolds number, its dimension is n power 0, l power 0, t power 0. So that will be eta power a. So that is m power a, l power minus a, t power minus a into rho, that is m power b, l power minus 3b into v power c, so l power c p power minus c into l power e. So that will be m power a plus b into l power minus a minus 3b plus c to t power minus a minus 3b. Sorry, minus a minus c plus b l power minus a minus 3b plus c t power minus l power minus a minus 3b plus c plus e. So therefore, a plus b that should be 0, so b should be equal to minus a, and minus a minus c that should be 0 also, so c should be also minus a. Now therefore, minus a minus 3b plus c plus e that should be equal to 0 also. So it means c that is minus a minus 3b that is plus 3b plus 3a minus a plus e that should be equal to 0. So e 3a minus 2a that is plus a plus e plus a is 0. So e is also minus 8. So therefore, it means if we take a as 1, then we take a as 1, then Re that will be equal to eta, Ra that will be equal to eta rho power minus 1 and V power also minus 1 and D power also minus 1. So this will be eta by rho Vd. And if we take A as minus 1, then Re will be rho Vd by eta. If A is minus 1. So now, so it means that either C or D we can take, but rho Vd by eta only we have to take. The correct formula for Reynolds number is rho v d by eta. So option C is the correct answer. And here it is told the terminal velocity Vt of the spherical raindrop depends on the radius r of the spherical raindrop as. So the terminal velocity, as we know, that is equal to 2r square into rho minus sigma g by 9 eta. Eta. So terminal velocity. So therefore, the terminal velocity is directly proportional to r square. So hence option C is the correct answer. And here it is told potential energy as a function of r is given as U equal to A by r power 10 minus B power r power B by r power 5, where r is the interatomic distance, A and B are positive constants. The equilibrium uh, distance in between the two atoms will be. So at equilibrium, dq by minus d by dr, that will be equal to 0. Since y force as a function of r, that is given as minus du as a function of r by dr. Now, therefore, we have to find the value of that R where the force will become 0. So du by dr, that is equal to, that is minus 10a by r power 11, then plus 5b by r power 6. Okay. So this will be equal to 0. So therefore, 5b by r power 6, that is equal to 10a by r power 11. So therefore, 5 is a r power 11 by r power 6, that will be equal to 2a by b. Therefore, r power 5, that is equal to 2a by b. R is equal to 2a by b and power 1 by 5. Option C is the correct answer. The bulk modulus of a liquid is 3 into 10 power 10 Newton per meter square. So the pressure required to reduce the volume of the liquid by 2%. So bulk modulus, as we know, minus delta P by delta V by V. So here it is told that delta V by minus delta V by V, that is equal to 2%, means 2 by 100. It's 1 by 50. The decrease in the volume of the liquid is 2%. So therefore, then delta P, I have to find how much pressure is required. So that is P into minus delta V by V. So that is bulk modulus, which is 3 into 10 power 10 into 1 by 50. Or I can say 2 by 100. So this will be 6 into 10 power 10 minus 2, which is 6 into 10 power 8 Pascal, which is or Newton per meter square. So 6 into 10 power 8 Newton per meter square. So option C is the correct answer. And here it is told a tube of length 5 centimeter is filled completely. Tube of length 50 centimeter. A tube is there. A tube is there, which is of length 50 centimeter. It is filled completely. Then incompressible liquid of mass 250 gram, which is 0.25 kg. A tube of length 50 centimeters filled with incompressible liquid of mass 0.25 kg. So 50 centimeters means 0.5 meter is the length. It is closed at both ends. The tube is then rotated in a horizontal plane about one of its ends. So it is now rotated about this end. It is rotated to its end with an uniform angular velocity omega, which is with angular velocity x radian per second, x root f radian per second. If f be the force exerted by the liquid at the other end, then the value of x will be how much? So here, liquid will exert a force. So the centripetal force that is m omega square r, m omega square n. So this much force only it will be exerted by the fluid, and the uh, other end of the tube will exert an equal and opposite force, which will provide the necessary centripetal force. F will be m omega square, and the entire mass will completely. So it means the entire mass will have the center of mass will be at the center. You can say this force equal to m omega square into L by 2. So the center of mass is at the midpoint of the tube. So here that will be equal to m, that is 0.25 into omega square. Omega square will be x square f into L by 2. L is 0.5 by 2, which is 0.25 only again. So therefore, f will get cancelled. So x square into 0.25 whole square, that is equal to 1. So therefore, x into 0.25, that will be also equal to 1. So therefore, x will be equal to 1 by 0.25 is 1 by 4 obviously. So x will be equal to 4. So the value of x is 4. 4 is the answer. And here it is told metal where is there, which is of length 0.5 meter and area of cross section is 10 power minus 4 meter square. As breaking stress of 5 into 10 power 8 Newton per meter square, a block of 10 kg is attached at one end of the string. A block of 10 kg, a block of 10 kg is attached, its mass is 10 kg, attached at the end of the string and is rotated in a horizontal circle. is rotated in a horizontal circle. Is rotated in a horizontal circle. The maximum linear velocity of the block will be. So the V max will be how much? The maximum linear velocity. So if maximum linear velocity of the block we have to find, it means the braking stress only has to act on the metal wire. So therefore, here will be the tension force. So tension that is equal to M. So V max or V I can say that is equal to L into omega. V equal to L omega. So omega will be equal to V by L. So tension force that will be equal to M omega square into L. So that is M E square by L. T will be equal to M square by L, and T will be also equal to sigma into area. Sigma into area, since stress is equal to force by area of cross section. So therefore sigma A that is equal to mv square by L. So therefore V square that is equal to sigma AL by M. So this will be sigma is the breaking stress 5 into 10 power 8 into area that is 10 power minus 4 into L that is 0.5 by M. M is 10. So this will be V square that will be 5 5 is 25. So 2.5 into 10 power 8 minus 5 that is 3. So this is 2.5 into 10 power 3. Or I can say V square that will be equal to 2500. That means V will be equal to 50. So the maximum linear velocity of the block can be 50 meter per second. So 50 is the answer. And here it is told the velocity of a small ball of mass 0.3 gram So here it is told the velocity of a small ball of mass 0.3 gram, or yeah, I can say 0.3 into 10 power minus 3 kg, and its density is 8 gram per centimeter cube, or I can say it is 8 into 10 power 3 kg per meter cube. It is dropped in a container filled with glycerine, and becomes constant after some time. V is constant. With the density of the glycerine, density sigma, that is 1.3 into 10 power 3 kg per meter cube, since it is told 1.3 gram per centimeter cube. Cc means centimeter cube only. Then the value of the viscous force acting on the ball will be how much? The value of the viscous force, that is x into 10 power minus 4 Newton. Then the value of x will be how much? So this is the viscous force. Then the upward force, that is the buoyancy force, and downward force, that is mg. So I will say uh, value of the viscous force, that is obviously mg minus the buoyancy force, which is mg minus v sigma into g. Now v I can say m by rho. So that will be equal to mg into 1 minus sigma by rho. This is the viscous force. Now that will be m, that is 0.3 into 10 power minus 3 kg, into g, that is 10, into 1 minus sigma. Sigma is 1.3 into 10 power 3 by rho, that is 8 into 10 power 3. 10 power 3 will get cancelled. So this will be 3 into 10 power minus 3 into, this will be 8 minus 1 by 1.3 by 8. This 7, 6.7 by 8 into 3 into 10 power minus 3. Okay. So 6.7, 7 is 21, 6, 18, 20 by 20.85, 7, okay. 7 is 21, 17, 20 by 8, so it's going to be 8 is a 16, 16, 45 is a 40. So it is approximately 2.5. Yeah, 21.1, so 8 is a 16, 16, 41, so 5 is a 40, so it will be 0, 8, 1 is 8, 70, 8 is a 16, so 2.512, this will be 2.5125, 2.5125 into 10 power minus 3, or I can say it is 25.125 into 10 power minus 4 Newton. So it is approximately, I can write 25 into 10 power minus 4 Newton. So the value of x will be 25. So 25 is the answer. And here it is told the speed of a transverse wave uh, passing through a string of length is 50 centimeter, which is 0.5 meter, and mass of the string, that is 10 gram, means I can say 0.01 kg. The speed of the transverse wave, that is 60 meter per second. The speed of a transverse wave, that is given as root over t by mu, where mu is mass per unit length. The area of cross section of the wire, that is 2 millimeter square, or I can say it is 2 into 10 power minus 6 meter square. And its Young's modulus, that is 1.2 into 10 power 11 Newton per meter square. The extension of the wire over its natural length due to tension will be. So the extension in the wire, that is delta L, over its natural length due to its tension will be x into 10 power minus 5 meters. Then x value we have to find out. So now we can say that T, the tension force acting on the where the string wave is formed, so that some extension of the wire will happen, that is delta L. So T will be equal to YA by L into delta L. So from here, velocity they have told. So from here, tension we can find that T will be equal to mu V square, where T will be equal to M by L into V square. M by L into V square. So this M V square by L, that is equal to YA by L into delta L. So L and L will get cancelled. So delta L will be mv square by YA. So mv square, m is mass, that is 10 gram. So 0.01 into v square, v is 60. 60 into 60 divided by y, that is 1.2 into 10 power 11 into a is 2 into 10 power minus 6. Therefore, this will be 1 by 100. So 0, 0 will cancel. So this is, for delta L will be 36. 6 here 36 by 2.4 into 10 power 11 minus 6, that is 5. So this will be 36 by 2.4 into 10 power minus 5. So this I can write 24 0. So 12 2 0 24 36. So 2 15 are 30. So this is 15 into 10 power minus 5 meters. So therefore the value of x will be 15. So 15 is the answer. And here it is told a string of area of cross section 4 millimeter square and 0.5 meter is connected with a rigid body of mass 2 kg. A string is there, a string having area of cross section, that is 4 millimeter square, or you can say 4 into 10 power minus 6 meter square, and the length is 0.5 meter. It is connected with a rigid body of mass 2 kg, and it is rotated in a vertical circular path of radius 0.5 meter only. The body acquires a speed of the body acquires a speed of 5 meter per second at the bottom of the circular path. So then the strain produced in the strain produced, which is epsilon, which is your delta L by L, when that will be how much? When the body is at the bottom of the circle. So that is something into 10 power minus 5, then that value will be how much, that we have to find out. And Young's modulus has been given as 10 power 11 Newton per meter square, and G value, that is we have to take it as 10 meter per second square. So here the tension force the tension in the string, so that will be obviously we can say here Ng will act downward. So the net force towards the center is P minus Ng. That is equal to the centripetal force, which is mv square by L. So tension, that is equal to mg plus mv square by L, and that will be also equal to the Young's modulus into the strain. T will be Ya by N into delta L, which I can say, so mg plus mv square by L, that is equal to Ya into x epsilon, which is the strain. So this strain we have to find out. So now, therefore, epsilon, that will be equal to m into mg into 1 plus b square by gl divided by a divided by ay is equal to mg, that is m is 2 kg, 2 kg into g is 10 into 1 plus b square, e is 5, 5 into 5 by 10 into L is 0.5 divided by AY, A is 4 into 10 power minus 6 into Y, that is 10 power 11. So this much, this will be the string. So this will be 20 into, will be 5 only, 5 will cancel, so 1 plus 5 is 6. 20 into 6 by 4 into 10 power 11 minus 6, that is 5. 4 5s are 20, so this is 30 into 10 power minus 5. 30 into 10 power minus 5, so therefore this answer will be 30. That is the answer. And here it is told the diameter of an air bubble, the diameter which is 2r, that is initially 2 millimeter. 2 millimeter is the diameter of the air bubble, which rises steadily, means V is constant. It rises with a constant speed through a solution having density sigma, that is 1750 kg per meter cube, at the rate of V is 0.35 centimeter per second, centimeter per second. The coefficient of viscosity of the solution is, and density of the air bubble is negligible. It means the density of the air bubble, we can take it approximately as 0 only. So it means there is no weight. The weight will be 0, that is V. Weight of the air bubble will be 0 only. So only there will be a buoyancy force, which is V into sigma into G, and the viscous force. Viscous force, which is equal to 6 pi eta RV. So when velocity will be constant, then the viscous force will be same as the buoyancy force. It means 6 pi eta RV, that will be equal to V rho into V sigma into G, where capital V is the volume of the air bubble, which is 4 by 3 pi r cube. Now from here, the coefficient of viscosity of the solution, which is eta, that we have to find out. So therefore 6 pi eta RV, that will be equal to 4 by 3 pi r cube into sigma into G, where sigma is the density of the solution. Pi will cancel, 2 is a 6, 2 is a 4. So therefore E is equal to r square will be there. So this will be 2r square sigma G by 9 eta. Or eta will be 2r square sigma G by 9b. Therefore, eta will be 2r square. R is 2 millimeter. No, the diameter is 2 millimeter. So the radius will be 1 millimeter, which is 10 power minus 3 meter. So this will be 10 power minus 3 whole square into sigma, that is 1750, into G, that is, so in poise we have to find, it means CGS unit. So poise, it means so 1 poisile, that is equal to 10 poise, you know. So it means 1 poise, that is equal to 1 by 10 or 0.1 poisile, where Quotient is the SI unit of coefficient of viscosity. So the answer which we will get, that we have to divide it by 10. Then we will get the answer in twice. So 2 into r square into 1750 is the density to G, that is 10 approx, divided by so it's 9V. V is 0.35 centimeter per second, or I can say 0.35 into 10 power minus 2 meter per second. So this much Poisson we will get. So this will be 0.35. So this will be 20 to 10 power minus 6 into 1750 divided by 9 into, this will be 35 to 10 power minus 4. So 5 7 are 35, 5 4 are 20, 7 2 are 14, 7 5 are 35. So 25 4 is again 100. So it's just 10 power 3 to 10 power minus 6 into 10 power 4, that will get by 9. This will be 10 power 7 minus 6, that is 10 by 9. 10 by 9 Poisson, which is approximately 1 by 9 twice. So here 1 by 9 is coming. The diameter is 2 millimeter. It's 2 into 10 power minus 3 whole square, 1750 into 10. So this will be 20 only. 20 into 10 power minus 6, 1750 by 9 into 35 into 10 power minus 2. 0.35 into 1 centimeter is 10 power minus 2 meter. 11 to 10 power minus 4. So this will be 25 for the 100. So this will be 10 power. So it will be 1000, 10 power 3 plus 10 power 4 minus 10 power 6. So 10 power 7 by 9 in Poisson. So in Poise we have to find is 1 by 9 Poise. So in Poisson only we have to find. So this is approximately 1 point. So today, in power 7 minus 6, so 10 by 9 Poisson. Now, 1 Poise that is equal to actually 10 Poisson. 1 Poise is 10 Poisson. Okay, so 1 Poisson that is equal to 10 Poise. 1 Poisson equal to 10 Poise. So I can say this will be equal to 100 by 9 Poise, which will be equal to 11.111 Poise, which is approximately 11 Poise. So the answer will be 11. So 11 is the answer. And here it is told in an experiment to determine the Young's modulus, steel wires of 5 different lengths but of same cross section were taken and curves in between extension and load were obtained. So it is the curve in between the extension and the load, means delta L versus F. So the slope of the extension by load, the slope of the uh, delta slope of extension versus load of the curves were plotted with the wear length, and the following graph is obtained. If the Young's modulus of the given steel wires is x, y is x into 10 power 11 Newton per meter square, and the value of x will be how much? So here, so therefore we know that F is equal to YA by L into delta L. So therefore delta L by F that we can say is equal to L by YA, L by YA. So therefore the slope of the extension load graph, slope of the extension load, extension versus load curve is nothing but L by YA, and A is kept constant. So the slope that is being plotted with the wear length. So L by YA, this value are being plotted versus the length, which means delta L by F versus L. So now the slope of this curve, slope of this given curve, that is equal to actually delta L by F by L into 1 by L. So that is obviously 1 by YL. Hence we can say from here delta L by FL that is equal FL that is equal to 1 by YL. So the slope of this graph that is 1 by YL. So here the slope of this graph that is 1 by YL. So then from this slope we can find Y. So therefore here the slope that will be equal to, we can take this point which is 5 meter comma, so is 1.25 into is 1.25 into 10 power minus 5 per Newton meters per meter square. Extension by load. This point we can take, this is 1 meter comma 0.25 into 10 power minus 5. Therefore, the slope will be y2 minus y1 by x2 minus x1, which is 10 power minus 5 into 1.25 minus 0.25 divided by x2 minus x1 5 minus 1, and that is equal to 1 by YA. Therefore, we can say 1 by YA that is equal to 10 power minus 5 into 1.25 minus 0.25 is 1 divided by 4. So therefore, YA that is equal to 4 by 10 power minus 5. It means Y that is equal to 4 into 10 power 5 into 1 by area of cross section. Now here the area of cross section is told 2 millimeter square, which is equal to 2 into 10 power minus 6 meter square. This 1 by 2 into 10 power minus 6. So this much will come in Newton per meter square. Newton's modulus. This will be 2 2s are 4. So 2 into 10 power 11 Newton per meter square. So therefore the value of x will be 2. So x will be 2. So 2 is the answer. So hope all of you understood the solutions of all these questions based on the chapter properties of matter. Still, any doubts if you have, please write that in the comments. We shall obviously clarify them. And please install our Sapience Education application also, where we shall upload some important questions based on the previous year JEE Mains exam on every chapter of physics, which shall be obviously helpful for your exam. So, so thank you everyone. Bye.